So, hey, on Monday I gave y'all, like I said, I gave y'all a worksheet, and it was over the t interval, the t interval and the z interval, right? What's the difference between t and z? Remind me.
The
When do
one
you,
you use. T is
okay,
before.
okay, but why? What tells us which one to use?
When you know the mean, when you don't know the mean.
You're close,
Standard
Aaron.
deviation.
Good, thank you. So one of them, as Shelby just said, one of them you know the standard deviation, the other one you have to use it from the sample. The z interval, you know the standard deviation, sigma's known. In the t interval, sigma's unknown and use it from the sample. We call it s. We're going to talk about these things called paired t complex intervals today, all right? Here's how this works. What? Oh, okay, listen up. So, in a paired t, here's what happens. You're going to look at your data. We do paired t-tests or paired t-intervals. When we know that the data is paired together, you know what that means is that you're either going to have a pre and a post assessment or a before and an after, or you'll be looking at a left and a right hand, something similar where you match two things together, all right? So the purpose of this is it compares the mean difference between paired sets of data. So the data has to be paired. And what you're going to see here is this. When you set up something paired, if you go down here and look at the actual notes, you see how you have a before and an after for this right here? They're treating this right here as the first subject. Here's the second subject. Here's the third. Here's the fourth, fifth, sixth, seventh, and eighth. So what you've done is you've taken a measurement before on the first person, and you're taking a measurement after the first after the first person. So what that does is it produces two samples. You understand that? What's the first sample called? Well, the first sample is the before sample. The second sample is the after sample. Everybody got that? Now, the problem with that though is this. When data can be paired, we are able to, this is actually the benefit of it, we're able to reduce the amount of variation. Because the data is repeatedly drawn though, because you're looking at it before and after, that means you're repeatedly looking at the same subjects from the same population, the data is not independent. And the reason that all of these intervals work is because the data is generally going to be independent. But when it's not independent, we run into a problem. So therefore, instead of looking at the individual samples, instead of looking at just the before sample or the after sample and doing an interval like that, we combine them by looking at their differences. We look at what's called the difference now. So I'm only interested in the difference between the pairs. And look at this example. A random sample of 8 students was selected to test for the effectiveness of hypnosis on their academic performance. The following table gives the GPA for the semester before and the semester after they tried hypnosis. So when I look at this data, look here, you have a before and an after. I'm only interested in the difference column though. I'm only interested in this column down here. Does everybody understand that? How do I find the difference? What do I do? Subtract what? So let's subtract the before from the after. So we're going to call the difference D. We're going to call the difference D. And D is equal to before minus after. So for instance, look at the first one. What's 2.3 minus 2.6? Thank you. It's negative 0.3. What's 2.8 minus 3.2? 3.1 minus 3.0. Positive 0.1. 2.7 minus 3.5. Negative 0.8, right? 3.4 minus 3.7. Negative 0.3. 2.6 minus 2.4. Positive 0.2. 2.8 minus 2.9. And then 2.5 minus 2.9. What I'm interested in is this. The sign can either be negative or positive. Does everybody see that? What does a negative mean? No, it means your GP actually did. So the after was what? Bigger than the before. Do y'all see that? If it is a negative difference, what do you notice about this? the after is bigger than the before. Will you see that? So after hypnosis, this person actually had a better GPA. Everybody got that? But after hypnosis, the positive means what? Their GPA did what?
Worse.
Went worse. It got worse. It went down. So write that out, please. A negative D equals an increase. A negative D is an increase in GPA. A positive D is a decrease in GPA. So the question is going to be this. Construct a 99% confidence interval to see if hypnosis improves academic performance. So if we're constructing an interval, what do I want to see with my interval? Do I want my interval to be all negative, all positive, or some negative and some positive?
You want it to be all negative.
Why?
Because you're trying to get the GPA to go up.
Good job, Aaron. So if it truly worked, if hypnosis truly works, we want to see more what? We want to see more negatives in the interval, right? Because if the interval is all negative, what does that tell me? If the interval was all positive, what would that tell me? They all went down. If the interval was negative and positive, what does that mean?
It's a mix.
It's a mix. And what does that tell me then about the actual hypnosis process? Does it work? We don't know if it works or not. That's what it really says. So let's go here. So we're going to create the interval next, and it's called the paired t-interval. The paired t-interval was performed the same way as the t-interval was. However, the interval was performed on the difference. Good. So we're performing the interval based on the differences. The interval itself is worked like this. We have this value which we call D bar now. What does D bar stand for? What kind of difference though? The average difference. This is the average of the differences. That's the average of the differences. It says D bar, plus or minus. What does T star stand for? What does T star stand for? It's called the critical value at degrees of freedom. How do you find degrees of freedom? N minus 1. Thank you, Shelby. N minus 1 times S of D. What does S of D stand for? What kind of standard deviation, though? This is sample standard deviation from the sample standard deviation of the differences. It's the sample standard deviation of the differences over the square root of n. Here's how we calculate the interval, all right? So, we're going to calculate the actual interval for this data right here. We're going to calculate 99%. In order to calculate 99%, what do I need? I need a D bar. How do I find the D bar here? Well, I have all these differences. What do I need to do? Find their what? Average. The easiest way to do this is put this in the list. So I want you to put this in the list. Let's go. Put in the list here. Remember how to do that? Looking at this, it tells me that, the calculator tells me that D bar is equal to negative 0.25. S of X, or S of D, is equal to 0.3162. So I have D bar, I have S of D. I know that N is equal to what here? Thank you. N is equal to 8. What am I missing? T star. How do I find T star? So we're at 99%, right? The degrees of freedom are 8 minus 1, which is 7. We want 99% inside of here, right? How much on the outside? How much is on the outside? 99% is inside. How much on the outside? 0.5. So I'm going to do inverse T, 0.995. Because you have 0.5 sitting on the outside, right? To both sides. So inverse T, 0.9957. And my T star is My T star is 3.499, so we'll say it's about 3.5. A solid 3.5. Y'all okay with that? Now, we just need to go back and plug into the formula now, right? So plugging in the formula, what comes first? D bar, which is negative 0.25 plus or minus T star, which is 3.5 times. Next is S of D, which here is, S of D is 0.3162 divided by the square root of N, which is 8. And now we know from our calculator that that's equal to what? The lower bound of this is going to be from negative 0.5144. The upper bound is from 0.14. I lie. Rewriting that. That's 0.0144. That's the upper bound. Now the question is, construct a 99% confidence interval to see if hypnosis improves academic performance. Based on this interval, does it improve academic performance? How do we know that how do we know we improved it? We said earlier to improve it had to be what? The entire interval needed to be what? Negative, because that increases the GPA, right? Is the entire interval negative? No. So has it improved it? Has it made it worse? We don't really know, because what number is sitting inside of here?
Positive.
Well, you have negatives and positives. What number sits in between negatives and positives?
0.
0. Because 0 is in here, what this is literally saying is that the difference could be 0. That's what you're saying. One of the possible values is 0. Here's how we talk about statistical difference. A statistical difference exists if the value of 0, I need you to change this too. If the value of 0, you can put the word right here, insert it into here. You put does not. It does not lie in the interval. I wrote that wrong in my notes. A statistical difference exists if the value of 0 does not lie in the interval. And what that means is this. If it improved it, which means it was statistically different, if it improved it, then its entire interval would be negative. If it was statistically different and it made it worse, then its entire interval would be positive. But because 0 is in there, if the interval is both negative and positive, this means a value of 0 is in the interval. And what this really means is that there is no statistical difference between the paired data. So what you're saying here is that because 0 is in the interval, we do not have, or we do not know, I'm going to say we do not have enough evidence to show that academic performance has improved. We do not have enough evidence to show that academic performance has improved. It could just be that people were going from their sophomore year to their junior year. And when people become juniors, they work a little bit harder.